All right, guys. Welcome to the Intro to Unity Shaders workshop. Today we're going to go over some announcements from Lewis, introductions from me and Nikita, who are going to be teaching the workshop, setting up the cozy world, so like setting up the environment for the game that we're going to be working on, creating the character and camera, and then Nikita's going to finish off with the shaders, and then we'll have a conclusion, just go over what we did. Here's
Yeah.
You go
So
ahead.
I'm pretty sure everyone already checked in, but if you haven't, just scan the QR code. It's gonna lead you to Luma to put your info, and then just let me know after once you've checked in. But I'm pretty sure everyone has, right? Does anybody need it? No? Yeah. Okay. All right. Cool. And then before we jump into the game dev stuff, if you can fill out this survey, it's kind of to judge how much skills you have for game dev, and what we could tailor those skills for the workshops. It's just to give us a better idea of what you guys are thinking and feeling and stuff. Did everyone scan it? Also, in order to receive the exclusive merchandise, if you do attend all 4 of these workshops, you do for sure have to scan this QR code. So, just as a heads up. And then as you guys are filling that out, I'm going to talk a little bit about Explore. It's one of the programs that we have within it. Essentially, it is a way to offer a little bit of a taste in different areas of tech for students that know little to none in these areas. So this semester we're going to have web development, AI, hardware, we just finished actually, game dev like these workshops, and also cybersecurity and UI after spring break. And yeah. And if you're not an INIT member already, I'd highly recommend it. You just visit that website, weareinit.org, or you can just go on our Instagram, the INIT FIU Instagram, and you can find all the details there on our link tree. But I highly recommend it. It's free and open to all FIU students. So, and then these are just some numbers of the impact that we have with our organization. Everyone loves numbers, so yeah,
Big numbers.
massive numbers.
They're huge.
Yeah, I'll pass it off to Nikita and Sam.
Thanks, Luis.
Hey, hello guys. As I said, my name is Nikita. I am a computer science student at FAU, and I'm learning computer graphics for 6 months. That's very interesting and diverse sphere. Maybe someone heard about it. I'm working with. Oh wait. Okay. I'm working with OpenGL mostly, without the any engine itself. I'm building engines myself. By this time, I used my knowledge to win one of the hackathons, so I'm pretty excited to see you guys today.
And then my name is Samuel Arminana. First started using Unity when I was 12. I got into it, and then uninstalled it, and then a year later got back into it, and really started to understand how to process it. And then slowly just kept using Unity, and got my first job when I was 18, my senior year of high school, working on 2 Nintendo Switch games, all Unity, and just stayed in the Unity world that entire time. And then I started at UCF 2018 and graduated 2021. Did my computer science, and then the last 4 years I was working as a senior Unity developer in Oklahoma on a ed tech platform for K through 6, so teaching math, English, and science, a little video game. And then my contract ended, and I decided to come back for my master's doing computer engineering here at FIU.
Okay. Yeah, and for this year's workshop, we're bringing something new. So instead of just teaching you how to build the game and the logic itself, we decided to split each of the workshops into 2 parts. The first where you actually building the game and the mechanics itself, and in the end we're polishing what you built with beautiful enhancing graphics and some beautiful designs. So yeah.
Nice shaders.
Yeah.
Yeah. So it's going to be we build the game out these next 4 workshops, and then we're going to have a special topic going over tools and high-end graphics. And then we're actually going to host a game jam if everything goes well, mid-April. So that's what we're working up to. So making sure that like everybody's prepared to like jump into a game jam and like make something. And then during the game jam, we'll have like a special edition workshop, like during it for a couple hours. All right, why Unity? So there's a huge use case with Unity. Like there's millions of users who are developers on it. So documentation's always there. If you have to make anything, you can look it up on YouTube, and 9 out of 10 times, like it's already been done. And the usage with Unity, um, like the output with the games, there's a the majority of Unity is in VR and mobile games. So 70% of the top 1,000 mobile games are using Unity. Like Hearthstone, for example, is a Unity game, and like countless others. The PC game, there's at least 28%, so there's still like usage in consoles and PC. But for VR, like Meta releases all their updates straight to Unity. Like they're developing on Unity, and so everything that they update goes straight into that pipeline. And so the last point too, there's multiple skill lanes that you can jump into with Unity. So you're using C# when you're coding in Unity, and those skills transfer over to like web development, APIs, like desktop applications. There's like a ton of use cases with C#. And like in January, there were 212 job listings for C# in Florida. And then on the bottom left, some revenue estimates. So mobile generates the majority of revenue, 108 billion. And then estimated players, 2.85 billion. So it's like nearly 3 billion people are using mobile devices. So you have a huge range of users with the mobile device. All right, and then next is like other use cases within Unity. So I got some companies that are using Unity right now. So Boeing, for example, is using it for augmented reality maintenance. So you put on like glasses and it tells you where you need to repair something. And that's all using Unity. There's lots of military training simulations, like with the Navy, with the Army, the Air Force, like those simulations that, like in Orlando is where a lot of military simulation happens, and there's like a conference that a bunch of people come and like showcase their products, and they have like a VR simulator where you have like a airsoft gun, and as you shoot in the game, like it pumps back. Nothing comes out, but it feels like you're shooting, and like you walk through like a treadmill and things like that. So they're using that for military training and like police training, things like that. Toyota and Lexus and Benz, they're using it for their infotainment system. So like the graphics that you see when you're driving, coming from Unity. And then digital twins also. So a lot of governments are creating digital twins of their cities. So for example, Orlando and New York, they're using it to like recreate the city and simulate traffic and congestion and things like that, so they can develop like the city a little better. And then lots of startups and contracting. Like you can always go on like forums, discords, and things like that, and find people who need like developers and jump on that. All right, installing Unity. I hope you guys all got to the Unity Hub.
It says here you need to install the latest Unity editor. It's taking a little bit of a while. Can I still?
Yeah, it's going to take a while. So you guys should have the Unity Hub, and then go to installs. Make sure you have the latest version. Still going? All right. We're going to need at least like 30 minutes. What percentage are you at?
It doesn't really say that in progress 3 out of 4 completed.
That's not bad.
The editor application is taking is at like 50%, and the get started on Unity is at 44. And the documentation and the web build support says install queue.
Yeah, that's fine. It'll take a minute to install, but Eventually it'll install. We have some content to go over too while it's installing.
No, I don't, this is just installing. So you can give it time to install. Correct. Smart.
I'm getting hot.
I was actually gonna bring my second one just in case somebody wanted it, but I forgot. Yeah.
Oh, okay.
He came prepared. He read the notion. Oh, it's through your Wi-Fi? You installed it here? Nice. Are you on the hotspot? He's chosen. He's chosen. Okay. Can you guys put your thumbs up if you're installing Unity or it's all like ready to go? Thumbs up, installing Unity. Everybody's good? All right. So we're going to go over a little theory while that's installing and go over what delta time is, because it's going to be an important topic while we're implementing the movement. All good? All right, so delta time, it ensures consistency across different frame rates. So if you have one device going 30 frames per second, you have another device going 60 frames per second, you need to make sure that like movement is matching up across those different frames. Like games in the past, like the Asteroid Blaster game that you like move left and right and like shoot up at like the aliens coming by, that is an example of like that game is frame rate dependent. So everything moves as everything gets processed, and so as you like destroy the aliens, there's less things that have to be ran, and so the game like naturally just moves faster through that. And if they implemented delta time, like that would, they would be able to control it separately from frame rate, but like at that time that didn't exist. So delta time and fixed delta time, these are two different like subcategories of delta time in Unity. The fixed delta time happens on a fixed update scale. Like that just means that the physics is operating in fixed update, everything else operates in update. So for movement, rotation, animations, and timers, that would be delta time. And if you're making, like if you're adding force to an object, you would do that fixed update. It probably doesn't make sense, but it'll make sense like as we like implement the player controller. And then you use it in update, not fixed update. It's just small things within Unity. And then it makes motion frame rate independent. So you can move at a consistent speed regardless of frame rate. So if you move forward 1 meter per second, 5 seconds later, they're going to be at the same position. And then this is like a little representation. Made it with AI, but it gets the point across. It didn't generate a rabbit underneath, but that's supposed to be a rabbit. And like, as you can see, like the frame rate can jump in between. like you have 0.033 seconds if you're running at 120 or 30 frames. 120 frames, you're running every 0.008 seconds. But yeah. All right, so we're gonna set up the project, set up the Cozy World. We're gonna import the assets and create a test scene. So we need to have Unity installed at this point. Is anyone still installing?
Yeah.
Two?
I'm sorry.
Okay, that's fine. We can still download the assets, get them get them downloaded. All right, there's a asset package that I prepared. If you go to this link, you can download it. It's a Unity package that we're going to import later on. Let me see.
Did you like open it, or just download it?
Just open it that. Okay. I just click in here. It says no icons. Should it be like that? Or?
Oh, yeah. Just hit File, Download,
Okay.
and download it.
You didn't have any luck downloading?
Dude, my Mac is so screwed.
Bro.
Something we didn't consider is I think I was telling you a lot of these computers have Ethernet. So technically they could just grab the Ethernet port from here.
And plug in.
The computers would be much faster. So look.
Not if you have a Mac.
Wait, are we connected to a
Yeah.
switch?
Not if you have a Mac.
Yeah.
No,
I have
you need a.
I have a dock.
Adapter.
Yeah, I have one too, actually. Hold on. What's your name?
That's
And after I download it,
Yeah.
do I hit new project to see what's inside? Or?
Yeah, we're going to start a new project altogether, but we're going to start a project. Not sure what happened.
I think it's loading.
Creating a project. Sorry for the dog.
No, no problem.
Are you allergic or anything?
No.
Oh, okay. He's a sweet boy. He doesn't hurt anybody. Just
No, it's
lizards.
service dog.
Just lizards. Say it again? Yeah, we're going to start a project all together. So once you have Unity installed, we're going to start the project all together. What's it say?
I mean, it's not installing. It's not downloading.
Oh, yeah, yeah, no, that's fine.
So.
The rest are short. The rest are super short. Well,
Speed up this incredibly, yeah.
come here. Do you install Unity, Annabella? You're joking. Bro, you ain't even following along.
it probably this is for Mac right
Unity 6.3 object now available, update for blah blah blah. Does that mean I'm good to go, or I still need to wait? Oh, wait, I still need to use the editor application.
Okay, guys. Make sure you go to this webpage and install the Unity package that's in there. It's like a Google Drive link. So you'll open it up and then
I never used Ethernet before, so I have no idea what the hell I'm doing.
So you're gonna go to the page and then find this, or actually, no, sorry. You're gonna find this page right here. Go to this page and download this. So you're gonna go to File and Download. All right. Yeah, can I get a thumbs up if everybody has a package? Package? You got it? All right.
The get started, the editor application still, which is the most important, get started or the editor application you import? That's it. These other two aren't so important. Documentation, what build support.
Okay. Now let's create a new project so we can import our assets. So we're gonna hit New Project, select the version of Unity that should be default, and we're gonna use Universal 3D. So you see there's different options here. They have pre-made templates, project templates for like VR, multiplayer FPS, for example, augmented reality, 2D games, things like that. But they have different options that are core. So these are like core assets. So if you're making like a VR game, an AR game, and then these are like 3D and 2D built-in render pipeline. It's a older version of rendering that Unity had. Now it has universal 2D, universal 3D, and high definition 3D. If you're making a game for like consoles or PC, you're gonna use high definition 3D. But if you're making a mobile game, you're gonna use universal. And then like a lot of games, there's a kart racing game. I forgot the name of it, but it has like a PC game and a mobile game and a web game. And they're using Universal 3D, and depending on the settings, it increases the resolution and like the texture size, model, fidelity, everything like that, based on whether it's a console, whether it's a mobile device, or like web. So you can make like one game and like port it to every platform. You have like you have to do more work depending on the platform, but like technically you can just make one game, export it to everything, and run, like I said, like on consoles, PCs, everything like that. So we're gonna use Universal 3D. Just keep it simple. We're gonna name the project Cozy World. And then just save it somewhere where you're not going to forget it, not going to lose it. And then just hit Create Project. So that's going to create a project and open it up. Is the stream still going, Lewis? Nice. All right, and then we're going to import the assets. All right, so we're going to see this new window. Let me explain like the layout also. You're probably going to see it like this by default. On the top left, so Unity is broken up into scenes. So all the content that you're making is inside of a scene. Like that's what contains the objects that are running. You can have multiple scenes open, or you can have one scene open at a time. But this is where you're going to store like playable content. Inside the hierarchy, you see the scene, and you see all the objects loaded with the scene. the scene view is actually like what you can see, you can move around, and you have in the scene, you have a camera, a directional light, and a global volume. The global volume is just like for VFX, like bloom or vignetting, which is like blurring the screen and like having like darkness around the sides, things like that. And then directional light gives you your scene light for objects, and then your camera is what you're gonna see when you open up the game view, like the game window. So if I move the camera around, it's probably not gonna look like much because there's nothing there. Um, but yeah, so then the inspector, if I click on an object in the hierarchy, I can see the properties associated with that object. And it's broken up into components. So all these things here that you can toggle up and down are different components. It's just like code that's running on this object is what that means. On the bottom, you have your project view. So these are all the files in your project. If I right click on assets, reveal and finder, you're gonna see this is the project folder that was made. And inside, you have your assets, your library folder, logs, packages, things like that. So everything in assets is what you're gonna see in the project view. And then, yeah, so that is the basics. I don't like this layout at all. I like the 2x3, primarily because it moves the project window up on its own window and it makes it vertical. And you can change to, if you right click on the window, change to one column layout. And it may, in my opinion, it makes like reading files a lot easier because you can open up folders and like drag things around. If I go back to default view, you can see I expand folders, but I can't see any of the content until I click into it. So if I have like subfolders and content inside of folders that I want to move around, it's like really hard. Like if I wanted to move the script somewhere else, I have to click into editor, find it, and then move it. So I'm gonna go switch to 2x3. I recommend switching for the workshop. So just go to, on the top right, from default, switch to 2x3. Right click your project window and change to one column layout. All right, and then we're gonna get started and import our package. So let's go into assets, open up Unity and the toolbar on the top, hit assets, and hit import package, custom package. And then find your package in your downloads folder or wherever you downloaded it. And then open it up. And it's gonna show a pop-up here. You can hit import. And this is gonna create a new folder here for, I believe it's third party.
Yeah. So the third party.
All right, and then let's open up our console. Like in the bottom, you can see there's an error. And so we open up our console, go to Window, Console, Window, General, Console. / Explorer Hub. Yeah.
I'm sorry.
Yeah.
Okay, which package or asset you said we downloaded?
You download it from here. You're gonna
Yeah, yeah.
y-
Which or you did
import all of it. Yeah, just hit import on the pop-up that comes up. All set?
I'm gonna count.
Oh, like installing Unity?
Yeah.
Oh, okay. In the meantime, can you go to this page and install this package?
Sure. Yeah.
go.fiu.edu/explore hub.
Explore.
Yeah, no space, all lowercase. And then you'll see this page. Scroll down and expand game development and go to this one.
Close the engine.
Yeah. And then in the top, you'll see a link for Google Drive.
Yeah, I see that.
And then go to it and just download it.
Yeah, I do.
Are you two set? Imported?
Mine's not even. This is my laptop. You said it's hers, and I know she downloaded everything, but I don't know which one of these is the one that I have to import now.
Go to your downloads folder. And open up the browser too. Doesn't look like it's doesn't look like it downloaded.
She said she.
It is.
That's.
Is the user interface the same on Windows?
Yes.
Yeah.
Two user interfaces
Primarily.
is the same.
Primarily. There's like 2 or 3 buttons that are not there. They're in different places. But
I just have bad experience with Apple, so.
I feel that. But Apple is God. Apple is God.
Question, does this also work, does Unity also work with Linux too?
Yes.
Okay, good.
Yeah.
Re-download it. It's fine.
But at your own risk. We had like one guy, remember when we did the cold run? He was installing it on Linux.
Oh yeah.
Is that bad?
It just ran into a lot of errors. You had to do like a lot of commands, and
Yeah. Okay. So you go to edit.
we just switched over to Windows.
Assets, right? Import package.
Stick to keeping it on Windows.
Custom package.
Yeah.
And then just find.
But you can run like applications. You can make like web servers that are Linux command line based from Unity. So you can make like your server and then export your like you build your server with the game. You export just the server as a command line application, and then you can run it in like DigitalOcean or AWS.
That feels incredibly complicated. I'm just getting started with this. I'm going to keep Linux.
It's a process, you know. You guys got it imported?
Assets.
How's it going, man?
Loading.
Unity's loading? Okay. There's one other person who is still loading for it also.
He'll get there eventually. Trust me.
I know, you're at like, what, 14 out of 17? No, 47 out of 57. You're soon. It's soon.
Eventually. Trust me. It's gonna be worth your investment.
All good? What happened?
It crashed twice now when I was trying to import.
Oh,
I'm
man.
gonna try running it through admin. Maybe that'll do anything.
On the Surface tab?
Surface Pro, it should be Surface Pro 11, so I don't know.
Does it crash when you open the project or when?
The first time was when I was opening a project, second time when I was importing. Maybe now it'll work.
It might be. If you have anything open, close it.
Yeah.
It might just not have enough RAM.
Yeah, I'm
'Cause
closing
it's-
every
yeah.
folder on my hand.
Alright, you can just hit import on that page.
Some merging problem. This package is gonna be like an issue.
No, that's fine. That's fine. That's what I want to go over. Have everybody open the console so we can clear it out. That's what we do. We just hit clear on errors. What's the progress on?
Before.
Oh man.
And that's a package thing. It's still only halfway through the third thing.
Yeah. Yeah. Once you import the package too, it's gonna be another wait.
Higher RAM, a little faster, and it has fans. So
It should have merge conflicts, right?
Yeah. So we're gonna go over that in just in a second.
That's why I like the class.
We're gonna have an error. So we just clear it out. This is what we're gonna do. I think we're only waiting on one other person.
Maybe he's good.
Him and him. He's good? Is he good?
Yeah.
Alright, I think just one more. Yeah. 56?
Oh, it's not. Why not just use the main
To
one?
another loading bar.
Yeah, it's still there.
Yeah,
Unless
it goes
it's
to a different one.
And register packages.
Yeah. There's like a package manager in Unity. I'll go over that actually right now. Just walk through the package manager. It will. It will. All right. So while we're waiting for a couple people to install and get the project up, I'm gonna walk over like the package manager. So if you go into your project, you're gonna see there's packages. If we reveal in Finder, we're gonna go to this folder, packages, but we don't see anything. We just see like a manifest and a packages lock. So if I go into this, it's gonna show. All right, it's gonna show this. You're gonna see the list of dependencies, and this is like npm packages or like yarn files. If you guys are familiar with web development, you're gonna use like npm for package managing, and it just tells the editor where to install your packages from and what dependencies you have. So these are all modules that Unity has. You can delete them, you can get rid of them, and not have access to like tile maps, web requests, vector graphics, for example. So if you're optimizing for file size and you're like making a mobile app, you want to delete everything that you're not using. And then the actual packages are in the library folder. So if you go to library and you go to your package cache, these are all the packages that Unity's installing when you open up the editor. It like checks your packages, makes sure that everything that you have in this folder matches up. If it doesn't, it deletes it. So you can make file changes here, but every time you open up Unity, it's going to reset. Yeah. So those are the packages. That's what you see here. And then, yeah, that's why it takes a little bit to install Unity also. Like it has to register all these packages and download them. All right. Once we have the packages installed, you'll see an error at the bottom. You can either click on the error or you can go to Window, General, Console. And then you'll see the console, you'll see the import errors. So there's like some warnings with the import. Those ones, normally we would worry about those and we would like fix it. So like this error is a merge conflict and then some warnings with the mesh loading and some files. Yeah. So what we're going to do is just hit clear on the console and delete all those import conflicts and just move on. So we'll close out of that console, and now you see we have our third party, and we also have a game folder. So in Unity, it organizes the folders based on alphabetical sort. So if you put an exclamation point, you get your folders up on top. And that's the process that I usually like to follow. So everything that you have related to like third party and assets, I like to put in a third party folder. Things related to our game, I put in the game folder. And you're gonna see when we made our project, we had all these files, things like that. what we're gonna do is delete the tutorial info. So this is like a README that gives you like a tutorial on how to use Unity. We don't need it in our package, in our project, so we can just delete it. So we're gonna hold Control or Command and select the two files and delete them. So tutorial info and README, since we don't need them. And then create a new folder in the assets, and we're gonna call it !engine. And we're gonna put all the assets related to engine files in this folder. So we're gonna select the input systems action, the scenes, and the settings. So if I expand the settings, you see I have these assets like a volume profile, mobile render, PC render, things like that. So that's what I was mentioning with the different settings you can have on PC and mobile. And these just define like the quality settings and graphic settings. And yeah, so we're gonna drag the folder, drag the scenes, and drag the input system actions all into the engine. And now we have organized assets folder view. So in the engine, we have the input systems actions, the scenes, and then the settings. So these are all things that the engine uses. We're not using it in our game, just Unity provides them. The input system actions, these are like the player controls. By default, Unity has it set up like a, like you have your attack, crouch, movement, jumping, things like that. And then UI interactions, etc. So these are by default. You can delete them and edit them. So if I click on the root, the input systems action, there's this button, Edit and Project Settings window. And then this opens up your project settings. This is all the settings with your project. Any changes that you make here also get moved like through Git. And yeah, you can change like your graphic settings, your like pipeline that you're using, and you can define other pipelines here. Then you have your input, physics settings, build settings, quality, etc. So input system actions lets you edit the action map. So you have your player UI. You can make a different action map. Like if you have like a different playable character, like zombies. Like if you're playing like as a zombie, you have different movement inputs than like a character. So yeah, we're gonna keep this. We're not gonna edit it at all. We're just gonna keep the default. We can close out of the engine and just not worry about it. And now the project is set up. We have in the project, I imported a package for character customization. So this is gonna be, like, we're gonna open this up and make a character. So you're gonna go to Unity, go to the top, and in the tools, like in the menu bar at the top, under tools, character customization, you'll see this window, and you can play around with it, make your own character. I'm gonna just keep randomizing. And then just name your character, let's just call it character 1. And then save prefab. And then you can close out of the window and find the prefab. You can open up the third-party folder, and it would be under the creative characters free, under saved characters. All right, and then we're gonna drag our character into the scene. So just drag him into the hierarchy. Click and drag that blue icon into the hierarchy. And then you have your character in the scene. So I could zoom in on them, double click on the object to put it in focus. And then like these are the objects associated with it. And we're gonna delete some of these components so we could create our own character system. So we're, by default, the package has like its own character movement, but we're gonna implement our own. So we're gonna remove the component, and it has a dependency on move player input, so we have to remove that first, and then we can remove the character mover, and then remove the character controller. All right, so we've removed the components, and then let's create a new empty game object in our scene. So we're gonna right click in the hierarchy or hit this plus button and hit create empty. And then we're gonna call it player. We're gonna expand the transform and zero everything out. So change all the X and Y, Z values to 0 for rotation, position, and scale will be 1. And then let's drag our character into this player empty game object. And so now you have the player and you have the character underneath. We're gonna also zero out the character position. So both the character and the player should be 0, 0 for X, Y, and Z. And then in the scene view, you can select like these different tools. So you have your move tool, your rotate tool, your scale tool. So I'm gonna select the move tool, and you'll see this is where the like pivot position is. Or actually here. So on the top, you have your center, you have your global and local, and then you have some other options. Like you can toggle the grid, you can change the grid size, and like other options. But like these ones are more important. The tool handle position has center and pivot. Pivot is where it's going to be rotating and moving from. So if I change the rotation, you'll see it's moving from this pivot point. If I change it to center, you're going to see if I change the rotation, I'm still moving from the pivot point, even though my tool is like in the center. Yeah. So I'm going to reset the position. Make sure this is set to pivot in the scene view. And then I'm going to select the player and add component for a character controller. So the character controller is like a collider, and it's going to create this green mesh around it in a shape of a capsule. And that just gives collision to the object. So as you're moving around, you're going to be moving like a capsule. So if there's any like rough edges, ideally like the character controller should just like slide off of it. And then like the character controller is different also from like regular physics. And the fact that it gives you options for like step offset. So if you're climbing up stairs, it'll automatically move the character up and like jump them up to the next position in the stairs, which you don't have in like regular physics. You would have to implement that yourself. And then, yeah, a few other things. But yeah. All right, so you got your player, you got your character. They're both zeroed out. You got your character controller on the player. We see this green mesh. And then it has options for centering, radius, and the height. So we're just going to change the center to 1, since the height is 2. So 2 divided by 2 would be 1. And so the center is just 1. And then we're going to create a new script in our game folder. So create a new folder in the game folder and call it scripts. And then create a mono behavior for player controller. So you're going to right click, hit create mono behavior, and then call it player controller. Yeah, just name it player controller. You guys good? You have your player controller script made?
Well, not yet. We're almost there.
Okay. You got your player controller script? Huh? Not yet? Do you got your character? Alright, let's set up the player. So create an empty game object, hit the plus on the hierarchy. Create empty. And just call it player. And then drag your character underneath the player, like into it. And then that made it a child, so you can hit like this button, like the arrows, so you can go up and down, left and right to expand. So we're gonna delete the scripts on this, but like the ones that came by default. And then this last one. And then they're all gonna be 0, 0'd. Perfect. And then you're set.
Yeah, that's for the scripts.
The fuck is this? Oh, okay. Okay. So that's what it was referring to. So you have your pivot, and that just changes like where you see the tool icon. Does that make sense? Like, how it works? All right, and then on the player, we're gonna add the character controller.
Moving the origin, it's moving, you want them to move.
Just everything to 0.
Okay, so the capsule collider, right? That's what we want them to change.
Yeah, the capsule collider should just be origin 1 for the Y. All right, so with the character controller is the collider, right? And then we just change that to 1 to just move the collision right there. And then you're good. We can move on. Or actually, you have to make that script. So we can unexpand that. We can also hide that. And in the game, create a new folder for scripts. You want to name it? Just call it scripts. And then right click on there and create a new mono behavior. Create mono behavior script. And call it player controller. And then you're all set.
Stopped it. Battery.
No space.
It turned on automatically.
Now it's running like a champion.
It's not even, there's no fans or anything.
He just blows on it.
The manual way.
I guess.
Did you make a script set?
Turning it on and off.
Yeah.
I don't think I should charge it. I'm not gonna lie.
You got this player controller?
Fully, I mostly did what I made a character, made the scripts, mono behavior, but I didn't do anything with the controller.
Oh yeah. Rename it to player controller.
This?
Yeah. And then you're set. You have your capsule collider on the player?
No.
So click on your player. And then open up the inspector. Let me see. Go to window, general. Yeah. General. Inspector. And then drag the little window over to that side. Right there. And then expand it. And then scroll down. And delete that. Right click on it. Remove component. And then remove the character mover. Remove component. And then right click on character controller. Remove component. And then go to your player and add component. Or actually set 0 for these 0, 0, 0. And then go to player. The player object. Click on it. Add component. Character controller. There you go. And then change the center Y to 1.
So, like final uses? No.
Perfect. You're all set.
Thank you.
Of course. The explanations made sense with the character controller and all that?
More or less, more or less.
It's just like a collider. It'll make sense like as you keep going through it, but just think of it as a collider.
Just checking the surface dog is allowed to be pet, right?
Yeah, of course,
Okay,
yeah.
perfect.
It's probably easier for some pets. Set?
Yeah, I'm good.
Are you?
So after you do the player building script, what else are you gonna?
Camera, and then Nikita is gonna take over. You gotta move it quick.
Yeah, just wanted to invite you a little bit.
Oye, ¿qué coño es lo que tú tienes? Yo siento que vale más la pena.
Are you following the workshop?
Yeah, I'm trying installing,
¿Qué paso es
but it's
este?
taking a
It's gonna
while.
take a minute.
¿Qué paso es este? Universal Render Pipeline Template. ¿Dónde es eso?
Create new project. Universal 3D, and then change the project name
Ah, ok.
to like cozy world.
¿Eso lo inventaste tú?
No, eso lo hizo Lee. Lee,
¿Quién es Lee?
la negrita.
Ah, ok.
Hay algo aquí para cargar el.
Aquí, en Abare.
No,
Mira, yo creo que para hasta $200 en un tent, gastas $200 en regalos para ella. Ese tent ella se lo va a pasar por el culo, muchacho.
Hit create project. Maybe one of you guys can follow along.
Bota esa computadora.
Did you download the package?
Yup.
Nice.
Este. Starter package.
Mm-hmm. Is it open? It's right there. Accept. Are you on the M4 or M5?
Yo creo que esto es M3. M3. Alright, you know how to do it? You import the package, you get your character. You got it? Is that recorded?
Yeah.
Oh, okay.
Just follow along as much as you can, you know. Import the package, just play around with it.
As much as I can. ¿Sabes cuáles son mis capacidades?
I know you got it. You got this. You guys are all set? Nice.
In the hierarchy, create empty. Create a player. And then drag him into the player. And then open that up. Like click the character. And just make sure he's 000 again. And then
Alright guys, once we have our player controller, double check that there's no spaces in the file name. Make sure that when you open it up also, so like double click it and it should open up Visual Studio Community
player controller, no space.
if you installed it, or like VS Code if you're on Mac. Hopefully. Okay, and then here you have your player controller. Make sure that the name of the player controller also matches one by one with the file name. Unity is very strict in like the file names matching up with the component. And like, as long as the model behavior matches up with the file name, you're good. You can make multiple classes even. Like if you wanted to, for example, I can make this class. And you don't have to follow along. This is just an example. So like I can make a class here for example, and like import it here as a field. And like I should still be able to import it. But like it's important that the model behavior, the names match up, and you should be good. So this is C Sharp. If you guys are unfamiliar, it's broken up into like object-oriented programming. So everything's a class, everything's an object. And so the file structure is basically at the top. You have all your imports. So if you're familiar with like Java or even like Python, you have like your import for packages that you want. And this mono behavior is coming from Unity Engine. So this is the class called player controller. It's inheriting from mono behavior. So that means it has everything that mono behavior has. And if you click into it, you can go into the source code and you can see the functions that it gives you. So it gives you like start coroutine, gives you like invoke repeating. So like everything that you would need in Unity is going to be coming from the mono behavior. So you can check like if the game's running, things like that. The import is just a namespace. So if I go into mono behavior, you're gonna see this is under the namespace Unity Engine. And so that's how we're able to import it from Unity Engine. If I made another namespace, for example, here, and I called it example namespace, and then I moved everything in example into it, now it's gonna show an error for example because I don't have it imported. So I can like right click on the error and like show context options. Whichever editor you're using, it should provide like these options. And so like if I import it, it just marks using Unity or example namespace, and then I get access to everything inside of it. All right, and so that's just a brief intro. So what we're gonna do next is actually we're gonna use ChatGPT to create our script. Because like now we have AI, so it's best that we learn how to use AI in the best way possible. And so we're just gonna use ChatGPT to go make a prompt all together. It's much faster than like us copying and pasting, just like from one script. And we're gonna go through, understand how the code works and like implement it. So just go to ChatGPT. You don't have to be like a premium user. You can just use the free model. So I opened up incognito and I'm just gonna type in create a player controller in Unity. And then we're gonna give it use the input system. Or use the use the new input system. So Unity, that input system that I showed you is one of the newer versions that they have. Before you would just do like key commands, and you would have to use assets if you wanted to create a game where you can reconfigure controls. You would have to do all that manually. But now with this input system, you can set that all up. You can reconfigure key bindings and things like that, like all out of the box. So we're gonna use the new input system and use a character controller. And then we're gonna also add in should move with WASD and have gravity. So that's all we need. We just need WSD and the character move with gravity. And then let's see what pops out. Okay, so it's gonna walk you through like creating the input actions. We're using the default one, so we don't really care about it. And then we have our player controller script here. So we're just gonna copy that and go back to your editor and paste it in. And again, make sure that the name of the class matches up with the name of the file. So it created these like variables at the top. When you're structuring your C# code, like you put all the variables that you have all at the top, and then these private variables. So if I save this and go into Unity, just like straight out, and I click into my player, and I drag my player controller onto the game object, No, you're good. So you're gonna see on the inspector, you're gonna see those two fields for the move and for the gravity. And you're gonna see like this movement header. So this header is coming from here, from this attribute, and like it's just a way for Unity, like for you to tell Unity to render like a label at the top. And then these values are public. Those are the ones that you can see. If it's private, it'll hide it from the inspector, and those values don't get assigned until you hit play, like until they get assigned here. So for example here, in the awake function, Unity has different like methods that control how code gets executed. So you have your awake method, you have your start method, and then you have your update loop. And so it's different steps. So awake gets called as soon as the object exists. Start gets called right after awake and every time you enable the object. And then update runs every single frame. So in the awake function, as soon as the game loads, we're getting the controller and running get component. So get component is coming from mono behavior, and it just lets you get another component on that object. So if we go into Unity, we see the player controller component. The character controller component is right next to it. So if we do get component, we can get all the other components in that, on that object. And we feed it in as a, like a generic type. So that just means there's less than signs and greater than signs, and that lets us type in like any class and like tell Unity that that's what we're looking for. So that's assigning the field character controller, getting the component. And then let's scroll down. One sec. All right, and then, so in our update, in our upwake, we're getting the component. Then we have this function onMove, and then, oh shit. Okay. So let's update this prompt, actually, because it generated something that we don't need. It's assuming that there's a separate script for player input. So we're going to say implement player input directly in the player controller. Oh man. And it's using the direct player input. Use the player new input system. Oh my god. All right, this is not what I was expecting. But all right, let's roll with this. Let's roll with this. Let's stay with what we had originally. Does everybody have like something that looks similar? Somewhat similar? Okay, so we're going to create a reference here, a public variable for input input action reference. So input action reference and call it move action and make it public. And then we're going to create a private void, like a new function in our class. So each of these are functions, like the awake is a function, onEnable is a function. So we're going to do onEnable. We're going to call moveAction.action.enable. And then we're also going to do moveAction.action.performed plus equals onMove. value dot. Okay. Yeah, so we have to implement the actual the perform event. So if I click into performs, you're going to see this is an action. In C#, you can have actions and you can like subscribe a method to an action. So whenever this performed method gets called, we're subscribing to onMove. And to unsubscribe it, we'll create a new method for onDisable. And we're going to do moveAction.action.disable. And then we're also going to do moveAction.action.performed, and then unsubscribe from onMove by doing minus equals. So now when perform gets called, it won't ever get called also. And then we can change this from public to private. It's mostly like organizational, but as we build up more scripts, you're going to see the value of like private versus public and like code structure. So when we call onMove, we're changing move input is equal to value.readValue. So we're going to read the output of that action and read it as a vector2. And then it's going to output back into a vector2. So a vector is just a like an x and y value, or a vector2 is an x and y. A vector3 is an x, y, z. And it's just like a vector with different parameters for like the variables associated with like x, y, z. So vector2 is just x, y. And so we're going to be mapping out the controls for w to be y1, a or s would be y negative 1, like going down, and then a x negative 1 going left, d positive 1 going right. So that's what it's going to map out to. And then in the update loop, we're calling handle movement. So we have a private void update. Like I said, this one gets called every frame. And inside of here, we're handling the movement and applying gravity. So in handle movement, we are updating the movement into a vector3. So we're changing it from an x and y to a vector3 x, y, z. Because when you're moving your character, when you're moving forward, you want to move in the z direction forward. You don't want to move like straight up in the y direction. So we're remapping it onto z. And then we're doing a check to normalize the value. So normalization, let's take a little pause. Okay, so normalization. So when you have a vector, like you can see on the image, if you have a 1, 1, like pointing to the top right, this goes beyond like a circle. Like if you were to draw a circle around, this is going to go past that circle. And if we're feeding like if we take that distance, we can see that like 1, 1 is actually like 1.5 units instead of like where it should be. So when we're applying the like speed to it, if if the length is past 1, like the length of the vector is past 1, then you're going to move faster in that direction. So there's some games where there's bugs where if you press like W and D at the same time, you move faster than you would like moving in one direction. So normalization, it's going to convert that length back down to 1 and like force the same magnitude for that vector. Does that make sense? All right, so even if it doesn't make sense, just realize you got to normalize the value so it's not like you're not moving in one direction faster than any other direction. That's basically what you have to remember. And then below, we're calling the move command on the controller. So we're referencing the controller, character controller, and inside of it, it has a move function. And the move function, if you hover over it or if you click into it by holding control and clicking in, you'll see it accepts a vector3, and then it implements like some native code. But what you really have to see is it's taking in a vector 3. So we take in the vector 3, and we're feeding in the move direction, multiplying it by the move speed, and then multiplying it by the time, that delta time. So that is one of the crucial points. That's like keeping the movement relative to your frame rate. So if you don't do this, you're going to have like frame rate dependent movement, but we want to convert it to a like second base movement. So just multiplying it by time, that delta time changes it from like per frame rate to per second, if you think about it that way. And then apply gravity is little like Unity specific, the way that it's implemented. So we're always moving down a certain amount, like pushing the character down to the ground. And then, yeah, so we're moving the character down to the ground, adding gravity. So gravity should be 9.81 meters per second. Multiplying it by time, that delta time, and then applying that velocity as a separate like direction. So we're calling move for gravity and for movement. So now if I go into Unity, because I added the input action reference, now when I go into Unity and I see the move action and click into it, I can swap between different input controls. So we're going to select the move input control. So you're going to expand your engine, expand input systems action, and just drag this player/move into here. Or you can click on the bullseye and it'll open up the list of options and just select the move action. All right, so then save your scene. So go to File, Save. You got your player controller, you got your character controller, you got your move action set up. And then lastly, we have to add in the ground. So when we hit play, I think the character is just going to fall down. So let me add a plane. So let's create a 3D object and create a plane. Okay, I pasted the code on Notion too, so you guys can just copy and paste it and get the same version. All right, and then in Unity, we have our plane. So we right-clicked in the hierarchy, hit Create 3D, hit Plane, and then it created a plane. So this is just a flat object. There's like no depth to it. It's just like totally flat plane. And then when we hit play, the character won't fall through and will land on top. And then we can press WASD and move our character around. But the direction does not reset, actually. So we're going to do move action.action. Cancel. Yeah, dot canceled, and then we'll also add in the move. All right, perfect. Now we're reading when the character lets go. So we added the canceled event here. All right, so we got our character. It's handling the movement. Last thing we want to do is rotate the character to match with the movement direction. So we're actually just going to take the code, put it back through ChatGPT. I'll start a new chat. So I'll refresh, paste the code. At the top, I'm going to put in rotate the character towards movement direction when moving. So that's what we want to do. We want to rotate the character to look in the direction that they're moving in. And then it generated this new script here. So let's import this into our code. So we have to update our handle movement class, like the method. And then it requires rotation speed. So we're going to update that. So what we're doing here is, I'll also update the notion just real quick. So what we're doing here is calculating the direction of the move vector. So we're turning it into a rotation, getting the target rotation of that move vector, and then rotating our character slowly towards that movement direction. So this quaternion.slurp is like a lerping function. It just slowly moves a value to the target value over time. And you have to call this like every frame. And it slowly rotates towards this target rotation at this time. So it rotates at the rotation speed times time.delta time. And yeah, that's the only part that we needed for the rotation. Everything else was the same. So now if I go back to Unity, go to our player, we can see rotation gets added with this header. We can also add in another header for the input. Actually not. But yeah, we don't need to. So I'm gonna hit play, and our character should rotate like as we're moving. There we go. All right. We'll just pause here and move over to the shaders, since that was a little bit. We were trying to get the camera in and some walking and idle animations, but that'll be catch up for next time. And then this is like ideally what things should look like once we have the animations in and we have like the camera set up. No. Let's do it.
Can you put the final code on the Notion?
Yeah. Yeah, the final code's up on the Notion, guys, in case you need to catch up. All right. Yeah, the final one. You guys have?
Yeah. How are you putting this one? Okay.
You got it?
Okay, I think I will try to only go with theory. I don't think we have time like to implement actual shaders. Okay, let's see how.
Let's see how far we go.
Yeah. Okay, guys. let's finish with coding for character on this point. Even if you like fell behind, we're gonna have the final code on the Notion page. So just keep an eye on it. What we're gonna move to right now is gonna make our game cozy. What we're gonna do, we're gonna use the thing called shaders. This is, okay, let's try with something small. I guess you guys know all these games on the screen. Can you guys name it? Somebody?
Silksong,
Little Company?
what's the middle one called?
Little Company.
Huh?
Little Company.
Lethal.
Yeah, Little Company.
And the other one,
Zelda. All right.
Oh, I can't see from
I guess you guys all like these games because of like fabulous gameplay and story, but we'll also like make them unique. It's like how they look like. So if you wanna like make a game that have the same quality of like artistic view, you need to learn the graphics, like how you can use different techniques to adjust your vision like to the player screen. So that's what we're going to talk about it. So what is meant by shader? Shader is like the small program that you run on your GPU, and it also like used for telling the GPU how like some object's supposed to be drawn on the screen. So it could be different parts. It could be like the color, lighting of the object, position, offset, size, and shape. The idea behind any GPU program you're writing is that you need to write one program that handles multiple inputs, and depends on like input gonna like run differently. So for example, in Unity and like most of the like graphics pipeline, you're gonna have two types of shaders. Whenever you're like trying to draw something on the screen, you're gonna just pass the raw vertices of like some object, which is gonna be processed by the rendering pipeline. It looks scary, but you don't have to understand it fully. So the only thing is matter, you have like two main parts, is the vertex and the fragment processor. So this is actually the shader programs which you run on the GPU. So the vertex is one which you passing like the geometry of your object, and you can change it. For example, move it or like rotate, like use it differently. But that's not the case of our today content. Today we're going to use only the fragment shader. That's the one which you pass the pixels, where the object is actually rendered, and it's going to output you the color of the pixels. So for example, if you render some sphere on the screen, it's going to adjust like some like pixels, which is going to be then passed on the shader we're going to write, and output the actual color. You have to understand that on GPU, any program you write is going to be like run thousands of times per second, like uniformly. That's the core idea. So let's write it. Let's do the first shader. So today we're going to make the material, the shader, implement UV mapping, use noise to blending, and use two textures for that. Okay, in Unity, there's a very important concept you have to understand. We have some kind of high-level abstraction with engine. So we using the shader, we're writing the program. But in Unity, we cannot just pass it to the rendering pipeline. We have to use thing called materials. You can think of it like if shader is like some recipe for the pie, and materials is actual execution of this recipe. For example, you have a recipe of the pie, and for example, you want to make it with the cherry, like make a cherry pie, or like maybe cook it with pineapple. So that's the case. When we're going to write the shader, we're going to allow users to do some input. For example, like the color of object, maybe some texture. And these actual inputs we're going to pass with materials. So that's general case. You have one shader, but like multiple materials. Let's go. So let's open the Unity project. And when we go to the game, we want to create a new folder in the art folder, and we want to name it materials. In this folder, we're going to create new material. Let's name it mat grass, for example. So what you can see when you open material, that Unity already provides like some shader, which is using by default. And on this shader, we can like change the input. For example, if you want to like make the base color of like red or something, we can choose it and save it right there. If you want to use your material on like the mesh you have on the scene, you need to like hold material and just drag it into the scene and put on our ground. If you don't have one, yeah, you have to create on the scene 3D object plane. So you're gonna have one.
Can you click into the plane and show them like the mesh component?
Yeah. So yeah, there's two options. You can just drag your material on the shape, like within the scene, or you can like click on your mesh, and in the inspector, you can actually choose the material you want to use. Right there.
Under mesh render, under materials.
Oh. What do you mean?
At the top, the material. Expand it.
Oh, yeah.
Yeah, and then that's how you can assign it.
Okay. Does everyone have material ready on the mesh? Can you raise the hand if you finish this part? Okay, nice. Okay.
You got it?
Oh, you still have. Okay.
Dad, can you hear me now?
Nice.
I'm in school.
So you have to create the plane on your scene first. So yeah, right click, not on the player, just the empty space, something right there. Yeah. 3D object. Yeah, and create plane. What?
I just did that.
Uh,
Is that not it?
yeah.
I mean, I shouldn't be funny.
Yeah, you have it on the scene. Like, can you click on this on the plane?
Mm-hmm.
But you see it's inside the player, I guess. Can you just take it like out of the player? Just yeah, put it somewhere on the scene. Yeah, right there.
Here?
Yeah, on the. No wait. Okay. Just create new one. No, don't care about it.
So,
Oh yeah, you have this one. So put the coordinates, the position like 0, 0, 0. Nice. So now you can. Well, you have two planes, right? Delete this one. Okay, nice. Yeah.
thank you.
You have your plane. You have material. Nice. You guys good?
Yeah, we're good.
Okay.
Like M18, like short material. Like this right here, the white. And then change it to yellow. Oh, you're gonna move like this.
Hey, how are you doing? Good? Okay. Do you have Unity? Yeah, install Unity, create account. I mean, it's just Unity. Unity Hub, and you can change the engine version within the Unity Hub. Okay. Okay, let's move forward. So as you can see, the material we just created is using the basic shader provided by Unity. But nobody stops us from making our own and like play around with it. So what we're gonna do, we're gonna go to the art folder again and create new one called shaders. And in the shader folder, we're gonna create a new shader graph. If anybody does not have option for shader graph, you have to go to the window, package management, package manager, and in Unity registry, you have to find the shader graph and install this one. But if you have shader graph, we have to create shader graph URP because it's our pipeline for the project. And you have two options. You can use the shader, which is gonna take the lighting from the Unity, or we're gonna use, in our case, shader which is not like care about lighting, because we're trying to make things simpler. So let's create shader graph, URP, unlit shader, and let's name it shader, for example, ground. So you can see we have a shader for our ground, but material like, for example, named grass. So in the future, we can like have one for grass, one for the sand, one for like any other kind of materials. But we're going to use the same shader for all of these cases. So let's create. And as you can see it opens a new window for us for shader editing. What I like to do is take this window and drag it like out right there and make it full screen. How are you doing?
I just got this, like the Xcode thing. I wasn't
Okay.
sure what you guys were like doing.
Is it unlit or unlit shader?
Unlit, yeah. So just go to Unity, yeah, and in the art folder, we have to create a new one dedicated for the shaders. Yeah, just create new folder. Yeah, right there.
Oh, just right here.
Yeah, yeah, yeah.
Create.
Folder, yeah, shaders. Nice. And in this folder, we're gonna create, right-click, create shader graph. Yeah, ERP, unlit shader. Wait, you can delete one. So delete this one, delete. No, just delete. Yeah, never mind, just wait. Nice, okay. Again, right-click, create shader graph, URP, unlit shader, the second option, yeah. So this is the one which is not using lighting for our case, so to make things simpler. You can name it, I prefer like putting two letters SH, so it's shader, and like underscore, ground. So this is the one we're gonna using for all ground materials. Nice. Yeah, and just open this one. Yeah, and I prefer like to put it out of screen. Just hold it, like, yeah, right there. On top, yeah. Wait. Wait. Oh, you have a full screen. So yeah,
Sorry.
get out. Try to do it again. Do it full screen. Yeah. Nice. And
Oh, that's a shame. Okay.
yeah, open it on full screen. Green button. Nice. How you guys doing?
We got it.
Nice. Nice. How you doing?
It's open.
Nice,
It
nice,
hasn't
but
crashed yet.
I prefer like if you taking this one like as the separate window.
As a separate window.
Yeah.
Okay. That is. How would I make it separate?
I can just take it like
Oh,
the
just
tab
grab
and
it
like
out.
put it
Or
out
up.
the window.
Okay.
Yeah. Then you can just like open it, adjust. Yeah. So you can see the full screen.
How big? How big should it be? Like here?
Yeah.
Thank you.
Okay. So what's the difference between shader and the shader graph? Usually, as a normal program, you have to like write in C syntax some program which is gonna be run on CPU, on GPU. But in Unity, we can use the blueprints to just connect the functions and nodes between them. So we can not using the coding in this case. So what we can see right now, we can see the free space. This is the actual space we're gonna like write the logic for our program. And right there, we can see like two parts of outputs we have to provide to like the GPU. So the upper part is the called vertex shader. Is the one we changed geometry. For today's lecture, we're not gonna speak about this. We only care about the second one, the fragment. So as you can see, as output, we need to provide the base color. And the base color has three components. So it's RGB, so red, green, and blue. We have to provide the vector, which is going to explain the GPU like what color the object's supposed to be. And right there, we can like choose the color. And if we're going to save and go to Unity back, we're going to see that our shader is like changing the plain color. If it's not, we need to go to Material and choose the shader we just created. So in the Material grass, we need to go right there, the shader, choose shader graph, and shader we just created, shader ground. So after that, it's going to be using the shader we just did. So you have to open the material. Yeah. And oh, nice. Yeah, good. How are you doing?
All right, so we put the color and what are we gonna?
So yeah, we chose the color. Can you go to material for? Yeah. So you can see right now it's using just a shader provided by Unity, but you can choose your own one. So you go into shader graph. Yeah. And you choose the one you just created. So as you can see right now, it's using.
Nice.
So voila, yeah.
Thank you.
How are you doing?
It's still yellow?
Hmm?
It's still yellow with the new one?
I mean, you can choose any color you want, actually. I'm just like using a random color just to show how it works. So the main part, I have to assign the shader to material. So if you go back to Unity, yeah, okay. No, wait. Click this one, go back, click this one.
It doesn't need
Oh, it's not clicking. Okay.
Uh,
Okay, let's.
and it won't go to it.
Let me try. Okay. Oh, yeah, because it's full screen. Okay. So in your grass material, as you can see right now, it's using the one provided by Unity, but we want to use our own shader. So we're going to shader graph and using shader ground. So right now, if you're gonna change the base color, like right there, to any you want, so it's gonna affect the shader. But you have to make sure you click the save button. Yeah. How are you doing?
Pretty good. So I made the color for the shader to be this. And
Yeah.
what else do I do now?
Yeah, just wait on this point. That's
Just wait
fine.
on this one?
Yeah, yeah.
Thank you.
How are you doing?
Yeah, it's I'm still trying to figure out how to go back to
Hmm.
normal thing.
So you can just click the minimize and I go back to Unity. Oh, wait.
Yeah, that's that. Yeah, because I maximize this, so
Oh, because yeah, because you just maximized it in the
ASH
Unity.
graph. Show in project. Nope.
Wait. Yeah.
Double click on the tab name.
Oh,
Oh,
okay.
thank God.
Nice.
It's so simple.
Nice.
Okay, no, this is actually.
I think maybe we can just jump in.
Yeah, I'll just make the texture at the end. Okay. But okay, let's move forward. If we're just providing the base color, it looks a bit boring because in our case, we could have like maybe some texture we want to provide to our mesh. So to do that, we can actually allow our shader to use some image to apply on the mesh we want. So if we're gonna back to our shader, we can try to create a new input our material can provide. So as you can see, on the left corner, you have to see this window. This is the actual part where we're gonna create the inputs for our shader. If you're gonna click the plus button, we can create a new input of type texture 2D. Let's name it texture 1 and click. So on this point, you have to be able to take the input we just created and put it on the actual shader graph logic right there. So yeah, as you can see, this is the input for the shader. We can like use any input you want. So in our case, we're gonna create a texture, so you have to use texture 2D. Yeah, and name it however you want, but I prefer just texture 1. How are you doing? Nice, okay. And you have to just put it like on the shader graph, like somewhere. Yeah, try to put like somewhere right here. And yeah, that's fine.
What's the path for the menu for the node?
What do you mean?
Like, this is the part I can't help them out as much in.
So you're supposed to have the input window. Why don't you have this one? Okay.
You can have her open that if that's what you need. There we go. But this is
No, it's not what we need.
what, because this might open it if I just add one. Not that. What's something simple? A math node. There's something missing in there.
Can you guys try to close the shader graph and open it again?
Yeah.
How are you doing?
frozen for me.
Okay. Waiting. Yeah, nice. And what you have to do, you can actually like move a little bit. Like, I prefer if this part is always be on the right, and you can just try to put it on the space. Now you can see this is like the options for input, but you can like take the object and put it on the space. Good, nice.
Not that one.
Nice. Okay.
It's still not showing up for her.
No, it's not right.
Yeah. Still not gonna help her.
Okay.
What were you gonna connect it to?
I'm gonna use like the function to make the sampling for the texture on the object, and we're gonna end on this point.
Alright, I'll keep helping see what I can do about this for you.
You can actually like try to do the direct input to the shader. Yeah. If you can just call the input, like call create new node, sampler 2D. Just type it. Sample.
What kind of, it might be the wrong type, no?
Oh wait, maybe actually. Wait.
Sample texture 2D, this?
Yeah. Yeah. And you can choose the texture right there. Okay. What we did on this point, we actually created a new input for our material. So if we open the project again and go to our material, but not forget to save the shader before that. So click on this button. And if we go to Unity, as you can see, we have a new option to give the texture for our material. So we can select the grass texture provided by package. So right now, our material has access to this texture. But we not explained yet how GPU can use this image. So right now, it's just image without explanation how to use this. What we're going to do, we're going to explain the GPU how we want it to be used. So you can do right-click and create new node called sample 2D. But sample texture 2D. And we have to call this one. And as you can see, this is the function that asks for several inputs. So we need the texture, which we already have in our material. So we can just use the texture and connect the nodes to the sampler. Here we go. So we can see we have all the inputs needed. And as output, we have several options also. We can choose the separate channels. But in our case, we want to use all 4 of them, as our color. And we're going to connect this whole stuff to our base color. And we're going to save. So if you go back to the Unity scene, as you can see, now our ground can actually use the texture we provided. How are you doing? OK. Nice. So because we have some problems with actually creating the input, you giving the default image directly to the shader. Yeah, but usually what you do, you have the option to getting input, where we can just adjust the image and use it uniformly. Okay.
Yeah, he's good.
Okay. One thing, as you can see, this function, the sampler texture 2D, is as we did before, using the texture, like the actual image data, and also using the UV0. Like, what the hell is UV0? Actually, when you like draw some object on the screen, you need to provide like the coordinates, like how some texture is supposed to be mapped on the screen. So this thing is called UV mapping. If we go back to our slides, so as you can see, that any mesh like you import or create, like within Blender or like import in your Unity project, is have the 3D model itself, and it also always contains the coordinates for the future texture could be used. So what we do in Unity, we just like take the actual texture, we use the actual coordinates, sample them together, and we get our texture on the screen. But there is one issue in our case. For example, when we're doing like our level design, we could have like several planes. So I'm gonna duplicate, but you don't have to copy this one. I just want to show something. If you, for example, have several like tiles, but of different size. For example, let's halve the plane and try to put it together. As you can see, the texture is used again and again on like each mesh. So when you're trying to stack them together, it looks like bad, actually. You see, right? And when you like creating level for your game, you could like have thousands of such meshes. And you don't want like to adjust each texture size and like change it depends on like what position it has. What we can do, we can provide a new coordinates for our sampler function. So if we go back to the Unity shader again, instead of like giving the function default UV coordinates, which is provided by the object we're using, we can create a new one. And it could be actually anything. By usual case in Unity, you can just use the world space coordinates. So for example, if we gonna use not UV provided by mesh, but gonna use just X and Z component of the world space, we can actually get the same output, but it's gonna look much better. So what I have to do is create a new node called position. Not screen position, just position. And make sure the space is set to world. As output, we have like 3 components. So usually these components is X, Y, and Z. But in our case, we need 2 components because it's texture, it's flat. What we need to do is take only X and Z components. So we create a new node called split. And we connect our position to this split function. What it does, it allows us to like interact with each of the component independently. Right there it says like RGB, but it's just a naming problem. Actually, it's XYZ. So R is X. So we need to create a new vector of like type vector 2, which is going to contain only 2 components. So we connect our R component, which is X, to the X, and our Z component to the Y. Yeah. So on this point, we created our new UV coordinates we're going to use. So right now, we can use the output from this vector 2 instead of our UV. and press save. So right now, what we did, we told GPU that it has to use the world coordinates to actually map our texture. And if we gonna back to our Unity project, as you can see, it tiled perfectly. So no matter like what place I gonna put the plane, it always the same. Even if it's like different size, could be like 10 or something. Wait. And it's always gonna be the same. That's the idea. Yeah, nice. Nice.
And save it.
Yeah, nice. Good. So we actually used to use much more content for the shader part, but since we're running out of time, that's all we covered for today. Yeah, but general idea is like shader is very powerful. If you like put enough time into it, it's gonna really like make sense. You can make your games very fabulous and beautiful. And we're gonna try to explore this content on the next workshops. Yeah, but for today, that's actually all we had. So thank you guys. Do we have anything on the slides we need to
Yeah.
show? Okay. Hey, pickles.
All right, there's an exit survey. If you guys have any feedback.
No, it's for the last workshop. Last workshop.
Oh.
Yeah, that's not today.
All right. No, we're good then. Let me cancel the recording.